Hello students, welcome to this part of the experiment. So the experiment we are discussing is to find the dielectric constant of a wooden disc. So this is the setup and this is a complete setup. This is written here, dielectric constant kit. Let me now briefly explain about this kit to you. So in this kit we have this switch, this black switch, it is for the standard capacitor. We can have two values of standard capacitor. If I put this black switch toward the left, now this standard capacitor SC1 will be used in the circuit. If I keep this in the middle, then it will be SC2. If I keep it on the top right, then the standard capacitor will have to be have to be connected in the circuit through these two terminals. Then it means you can put external capacitor of your choice. Now there is a switch. This switch, it is written as a selector switch, and there are two pins. This pin and these two pins. These pins are for dielectric capacitor. So we will insert the wires or the terminals of dielectric capacitor in these two terminals. I will be using only capacitor number 1, standard capacitor number 1. So we will keep this black switch to the top left position. Dielectric capacitor will be placed here. This is the calibrating knob. By using this knob, if we move this knob in the clockwise sense, then the frequency of the AC voltage that will be supplied to the circuit, it can be changed. The frequency can be adjusted from 0 to 20 to 2000 hertz. We can use any frequency from 20 to 2000 hertz. So I will be skipping this part in the experiment. I will tell you calibration of this experiment in the next part, when we will be familiar with how to use a CRO. So we have to calibrate this circuit first with the CRO, that is cathode ray oscilloscope. We can connect the CRO terminal here, then we can select a frequency which will produce sinusoidal waves. So with this calibration button or knob. So we are going to skip that part, and this is a display panel. This display panel is for voltage. So this is the reading of the voltmeter. This voltmeter has a terminal which is connected to selector switch. This selector switch can be turned up or it can be turned down. When this knob is turned down, then the voltage whatever is displayed on here, it will be the voltage across dielectric capacitor. Means the reading in that case here will be that of VD. Similarly, if I turn this knob up, then you can see now it is pointing towards standard capacitor. All these three are standard capacitors. So we are, of course, out of these three, we are using this first one. So whatever is the display here, in that case, it will be the value of the voltage across a standard capacitor. So that will be Vs. Okay, so Vs and Vd, both of these voltages will be on this display, and this switch will be used to automatically connect across standard capacitor as well as dielectric capacitor. So this is a starting knob. So and you can see these two wires are actually connected to these metal plates. So these two are the metal plates. So this is metal plate number 1, this is metal plate number 2, and these two wires are connected to these metal plates. So we have to connect these, make a capacitor using these plates. So this is a wooden disc. I will place this wooden disc on one of the capacitor plate. Then I will place this is capacitor plate, second plate on this wooden disc. Now you can see this is a capacitor filled with medium. So I will place it like this. So you can connect these terminals with this. So now the dielectric capacitor is in the series with the standard capacitor, as I have explained in the first part of the experiment. So now this dielectric capacitor is connected. Kindly remember, standard capacitor is inside. So on the top of this, I have written down the values of the capacities of the standard capacitor number 1 and standard capacitor number 2. Mind it, standard capacitor number 3 is not inside the kit. It has to be used by ourselves. If we are not satisfied, then we can use standard capacitor number S3, SC3 of our choice. So on the top you can see, on the top you can see this is a standard capacitor value written. So for SC1 this value is 50 picofarad. So kindly excuse me, because in the first part of the experiment I wrote this value to be 50 microfarad. Actually it is 50 picofarad. And if I keep the black knob at SC2, then this capacity is 170 nanofarad. You can see here. So this is for this the capacity is 170 nanofarad, and for this the value is 50 picofarad. So I have kept this knob to the left, so therefore the value of CS is 50 picofarad. In the first part, when I was explaining the theory, by mistake I used this value to be 50 microfarad. So actually we will be using it to be 50 picofarad. Kindly make a note of it. Okay, let me now switch on the circuit. And when I am switching it on, you can see there is a voltage display. Let the voltage settle. Okay, you can see this voltage is 2.29 volt. And you can see also this knob is upward. So this is the value of Vs. So Vs is 2.29 volt. Let me shift this voltage downward. Okay, this value is 2.43 volt. So the value of Vs is 2.29 volt and the value of Vd is 2.43 volt. Let us take the second set of reading. So I am changing the frequency, and with the change in frequency you know that if we change the frequency then the reactance will change, and if reactance will change then the voltage will also change. Now you can see for second value of frequency I have changed the frequency of the AC voltage that is passing through this circuit, so or AC current which is passing through this circuit. You can see the value of Vd is now 2.34 or 35. It is you can take it to be 2.35 volt. Let me shift the knob upward. Let it settle. So it is 2.38 volt. So this is the value of Vs. It is 2.38 volt, and the value of Vd it is 2.36 or 35 volt. So there is very small difference in the values of the voltages for this frequency. Let me take third set of the reading. Okay, now you can see here the value of Vd is 2.32 volt. Okay, let me switch it on upward. Yes, this value is of this is Vs. It is 2.40 volt now. So now we have taken three sets of reading of Vs as well as Vd. Let us now do the second part and find the value of the thickness of the wooden disc and the diameter of the this capacitor plate. For that I will switch off this circuit. We will take out these knobs, and then I will take this brass plate, and after taking this brass plate I will measure the diameter of this brass plate with the help of a vernier calipers. So this will be the vernier calipers. So I will not take live readings because of the small very small accuracy of my phone or camera. So therefore I will take the screenshots, then explain the readings. I will find the diameter using this vernier calipers. I will find the diameter of this brass plate. Then I will use this wooden disc for, because we have taken readings with this wooden disc. So I will take this wooden disc and I will measure the thickness of this wooden disc, that was small d. Kindly use, so remember I used symbol capital D for the diameter and small d for the thickness. So I will use this screw gauge. This screw gauge will be used for finding the thickness small d of the wooden disc. Let us now do that part and then we will do calculations. Thank you. Yes students, welcome to this part of the video related with the experiment to find the dielectric constant of a wooden disc. Now I have this vernier calipers in my hand. I have taken the screenshots because during making video it was not possible for me to make this uh, good resolution observations. Now I have taken the screenshots. You can see this is the zeroth of the main scale, and this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is actually 1 centimeter, and you can see there are 10 divisions and each division is 1 millimeter away, and this is the least count actually main scale. So you can see the these are the 10 vernier scale divisions. You can count these. This is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So you can see that 9 main scale divisions are coinciding with the 10 vernier scale divisions. And you can also see that this line, which is the 0 of the vernier scale, it is in it is completely coincident with the 0 of the main scale. So hence the 0 error of the vernier calipers is nil. So let me now go to the observation and then we will add this. So 0 error in vernier calipers is nil. Let us write this value in our calculation. Okay, you can see here that 0 error of vernier calipers. So I am writing it to be nil. Since 0 correction, you know that 0 correction is negative of 0 error. Therefore 0 correction will also be nil, or you can write it to be 0 centimeter. So this is the first part. Let us now take the calculations of the diameter of the vernier by diameter of the capacitor plate using vernier calipers. Okay students, now we have taken the note of 0 error in the vernier calipers. So let me now take the readings for the diameter of the capacitor disc. So this is how I have holded the capacitor disc plate between the jaws of lower jaws of the vernier calipers, and to take the reading we have to zoom in to this area where the vernier readings are there. Let us go to that screenshot. Okay, now you can see this is the disc. You can see this disc is placed here, and this is the reading. Now you see here that I have taken this zoomed in screenshot to calculate the readings accurately. You can see here that the reading of the main scale is 7.5. This is 7, this 7.1, 7.2, 7.3, 7.4 and 7.5. So main scale reading is 7.5. Now to take the vernier scale reading, you can see 0 of this is to the right of it. So the actual reading should be more than 7.5. How much it is more? Let us see it. So first is not matching, second is not matching, third is in more agreement, you can see there, and fourth is to the left. Now the readings are started to the left. So you can see this first, second, third. So third reading is coinciding with some reading of the main scale. So the reading of the vernier calipers or the diameter of disc at the first position is actually 7.53 centimeter. So we will remember this value. So now I have rotated the disc and I have taken the screenshot of the diameter using this vernier calipers at different place. So let us see that second screenshot and let us see what is the value. Okay, you can see here again. So this reading, which is the vernier reading, it is again after 7.5 and before 7.6. So the main scale reading is 7.5, but it is to the right of 7.5, so 7.5. So the actual reading should be more than 7.5. To see that, we will see, now you can see this line and this line are not coinciding, and this line is coinciding. So this is actually second reading of the vernier scale, which is coinciding with some reading of the main scale. So after that, the third reading is not coinciding, fourth is not coinciding. So the maximum best matching is for the second division. So therefore the second diameter measured from the second observation is actually 7.52 centimeter. So now we have measured two diameters of the disc. One is 7.53 centimeter and other is 7.52 centimeter. Let us now write these readings here. So you can see here. So D1 diameter of the plate is actually 7.53 centimeter and D2 is 7.52 centimeter, and main diameter will be 7.53 plus it will be average of these two. If we add and divide these by 2, then the answer will be 7.525 centimeter. It will become 7.525 into 10 raised to power minus 2 meter. So one part of observation is over. Let us now take the readings with the screw gauge. Let me show you the next reading. Now this is the screw gauge. You can see both of the studs are in contact with each other, and when these studs are in contact with each other, then you can see this is the reference line or the of the main scale. And you can see here this is 0, this is 10, this is 15. If you count this, this is 16, then 17. Yes students, so this is 15, 16, 17, sorry, this is 15, 16, yes, 17, this is 18. So 18th division is coinciding with the 0th division of main scale. So there is an error, positive error of 18 divisions. It is in millimeters. So the least count of this screw gauge is actually 0.01 mm. So there the error is 0.18 mm. So correction will be minus 0.18 mm. Let us now write this on the observation table. So least count of screw gauge we have written, least count of vernier calipers we have written. We have already noted down the errors and correction in vernier calipers. So zero error in screw gauge, it is 0.18 mm, and zero correction will be equal to minus 0.18 mm. Now let us now find the thickness of the disc. You can actually write the disc here like this. So let us now find the diameter of the thickness of the disc using this screw gauge. So this is the next screenshot. You can see this. I have here folded the disc between the studs. Now you can see this is the main scale. So 0 mm is visible, 1 is visible, 2 is visible, 3 is visible, 4 is visible, and 5 is also visible. So it means main scale reading is 5, but 6 is not visible. So therefore it is more than 5 and less than 6. Now if you can see this is 0, this is 5, and if you can see this is actually 6, and 6 is is coinciding with the reference line of the main scale. So therefore the circular scale reading is 6 divisions, and 6 divisions means you multiply 6 by least count, it will become 0.06. So if we add both of the readings, main scale reading is 5 mm, circular scale reading is 6 into 0.01, that will be 0.06. So the total reading will be 5.06 mm. This is the thickness of this wooden disc at first place. Now I have taken another the thickness reading of this disc at another position. Let me find that. Okay, this is the screenshot. You can see here that this is 10, this is 15, and if you can see this is 16, this is 17. So this is 17th division on the circular scale is coinciding with the reference line of the main scale. So the if you multiply 17 by least count, it will become 0.17. If we add both of these readings, so the main scale reading is 5 mm because 5 is visible, and the circular scale reading is 17, 0.17. Okay, students, this is main scale reading that is visible is 5, and the circular scale reading is that this is 15, this is 16, this is 17. So 17th reading on the circular scale is matching with the reference line of the main scale. If you multiply 17 by least count, it will become 0.17. Since on the main scale 5 mm is visible, so main scale reading is 5 mm. So it is this circular scale is actually to the right of the this ring of the circular scale is to the right of 5 mm. So the total reading of this thickness is actually more than let us say 5 mm. So therefore if we add to both of these readings, so 5 mm added with 0.17, it will become 5.17 mm. So now we have taken both of the readings of the thickness of the wooden disc. Let us now write both of these readings on the observation table. So this was the case. So first reading was 5.06 mm, and this was 5.17 mm. So if you add both of these and divide by 2, then your answer will be 5.06 plus this 5.17 divided by 2, it will become 5.11 and 5 mm. This will become 5.115 into 10 raised to power minus 3 mm. And let us now write the, because this screw gauze, it has some error, so the corrected thickness will be small d, it will be equal to observed value plus zero correction. ZC stands for zero correction, and this will be 5.115 in mm minus, because the zero correction was minus 0.18 mm, so this will become 0.18 and it will be mm. And if you solve this, your answer will be 4.935 mm, that will be 4.935 into 10 raised to power minus 3 meter. So let us now take the value of voltages across capacitor, standard capacitor and the dielectric capacitor, then we will make the calculations. So and also let me now make the correction. So this was the correction that has to be made. So I have already told you by mistake I have written here 50 microfarad while giving the description, but actually this standard capacitor is 50 picofarad. So let me now correct this value, and this value will be actually 10 raised to power minus 12 farad, and it is given to us. So sorry for that, I quoted wrong value while describing this experiment. Let us now move to the next part. So we have noted down the values of the readings of the voltage across standard capacitor and that of voltage across the dielectric capacitor. So rather I will actually make prefer to make a table. I will erase this part of the observation. So let me make the observation table. So observation table will be like this: observation table for dielectric constant. So serial number will be there. After that, there will be one value of Vs, there will be one value of Vd, there will be Cs, dielectric constant K. It will be equal to 4D Cs Vs upon pi capital D square epsilon naught and Vd. So we will note down all these readings and then find the mean value of dielectric constant K. Let us go for this. So serial number 1, let us write down the values of Vs and Vd that I have described in the previous part of the lecture. Okay students, as described in the video, I have written here the values of Vs and Vd for three different sets, and these values have been obtained by marginally changing the frequency of the circuit voltage that I changed with the help of knob. While changing the frequency, we must take into account that the voltage signal must be sinusoidal while passing through the circuit. So that thing is taken care of with the help of CRO, and I have skipped that part in the experiment. So let me find these calculations and tell what is the dielectric constant for our three values of this. Then we will find the average value of dielectric constant. Okay students, I have found this value of dielectric constant for three different values. Let us now find the average value of dielectric constant. It will be the sum of 5.91, 6.35 and 6.48 divided by 3. Actually these are more in agreement with this. There is a huge difference. We could have neglected it also. So then the final answer will be the average of these three. So the average of this value will be 6.25. 6.25. Therefore, our conclusion is dielectric constant of given wooden material is 6.25. So that was the answer. If some student is interested, let us say, in finding the polarizability, so we can also find the polarizability of this wooden material. Let me erase this part. So polarizability alpha, it is given by epsilon naught multiplied by K minus 1 multiplied by volume of the wooden disc or wooden material. So it was 8.854 into 10 raised to power minus 12. It was coulomb square per Newton per square meter, and K is actually 6.25. This will be minus 1 multiplied by volume. So volume is nothing but it is the product of area multiplied by thickness. That was actually pi capital D square by 4 into small d. So you can write it, multiply it by pi, that was 3.14 divided by 4 into d was actually 7.525 into 7.525 into 10 raised to power minus 4, and then we will multiply it by small d, that was I guess it was 4.935 into 10 raised to power minus 3. So this will be in meter, this will be in meter square, sorry. this area will be in meter square and this will be in meter, so I can multiply it by meter cube. So the final answer will be as follows. So this value will come out to be this one, and if I evaluate it, it will become 1.0 uh, it will become 1.019 7 into 10 raised to power minus 15. It will be coulomb square into meter per Newton. So this will be volume polarizability of the material. So I hope you will find this experiment very informative. Thank you. Thanks a lot.